Hello and a very warm welcome. I am Chinmay of MIT Aurangabad and I am here to present a review on nanocellulose based biodegradable polymers. Currently, I am working as a research intern at the Defense Institute of Advanced Technology, Pune. This is an in-plant training review under the guidance of Professor Balasubramaniam Kanda, Department of Metallurgical and Materials Engineering, Defense Institute of Advanced Technology, Pune, and Ms. Suranjana Mandal, Department of Plastic and Polymer Engineering, Maharashtra Institute of Technology, Aurangabad. This slide shows the documents for nanocellulose-based biodegradable polymers. The graph shows the documents by year that have been published from 2013 to 2020. Precisely, these are the documents that have been published from the year 2013 to 2020, showing 2019 has the highest number of documents that have been published. These documents include research articles, review articles, book chapters, books, conference papers, etc. Literature survey. Literature survey was done in order to showcase different types of researches that have been done in the past few years. Nanocellulose fiber, for example, nanocellulose fibrils and polylactic acid was combined to form nanocomposite films using solvent casting method. Similarly, solvent casting method was used to prepare biodegradable polymer films of polyester films of PLA and PHB with nanocellulose as the reinforcement agent. Several other researches have been showcased in this literature review. Another example of carboxymethyl cellulose and carboxylated cellulose nanofibers, which are cross-linked using citric acid to form green superabsorbent polymers. Similarly, biopolyurethane, tartric acid, and nanocellulose were combined with their suspensions to form composite films. Nanocellulose-based biodegradable polymers. The zest of the nanocellulose based biodegradable polymers comes from the material cellulose. Cellulose is one of the most common available polymers. It is also the most widely used biopolymers. Um, uh, cellulose particles having any dimension in the nanometric scales refers to as nanocellulose. Nanocellulose and materials based on nanocellulose. Materials that are based on nanocellulose includes incorporation of nanocellulose as a reinforcement agent. The nanocellulose is reinforced in polymer matrices like PLA or PHB that have a biodegradable nature. Nanocellulose can also be used for the incorporation in synthetic polymers uh, uh, on the condition of not being biodegradable. Advantages of incorporation of nanocellulose. Nanocellulose in recent years have gained keen interest virtue of its inherent properties like biocompatibility, low cost, non-toxic nature, vitality, etc. And is widely used as biomaterials for several applications like biomedical applications, food and packaging, hydrogels, energy, and many more. Classification of nanocellulose and their sources. Nanocellulose are mostly extracted using the plant sources, the wood pulp being the most common source of cellulose. Cellulose are found in the inner plant cell walls of the plants. Uh, algae and bacteria segregate some of the cellulose in them. Particularly, green algae is the most commonly used source for extraction of cellulose. Tunicates are marine animals that segregate cellulose on the external body. Classification of nanocellulose. Nanocellulose are classified into three types: cellulose nanofibrils, cellulose nanocrystals, and bacterial cellulose. Cellulose fibrils are the most commonly used reinforcement agent for the polymers. Cellulose nanofibrils have a fiber-like structure and a dense network. Whereas in cellulose nanocrystals, these have a rod-like structure and are mainly produced by acid hydrolysis. That means hydrolysis of the cellulosic sources using a strong acid like sulfuric acid. Bacterial cellulose. The cellulose extracted from bacteria is known as bacterial cellulose, wherein these have a very fine and dense network. Also has a ribbon-like structure. These are the images or transition electron microscopy images of the three types of nanocellulose. It is clearly shown it has a rod-like structure, whereas nanofibrils have a fiber-like structure. Bacterial cellulose shows a very fine and dense network of ribbon-like structures. Preparation methods and pre-treatments for nanocellulose extraction. Some pre-treatment methods are grinding, acid or alkaline hydrolysis, ball milling, chirocrushing, etc. The following image represents preparation methods and pre-treatments for the extraction of cellulose. Pre-treatments are particularly done to remove the excess materials like lignin and hemicellulose from the cell walls to obtain cellulose. Pulping and bleaching is the most commonly used technique, wherein it includes dissolving the cellulosic sources into water and treating it with chemicals to extract cellulose. Further, after the pre-treatments, they are subjected to alkaline or acidic hydrolysis. Alkaline hydrolysis involves using NaOH or potassium hydroxide as for the hydrolysis, and acid like sulfuric acid, tartaric acids, or HCl can be used as for the hydrolysis. This alkaline or acid hydrolysis produces cellulose nanocrystals, mainly cellulose nanocrystals. Several mechanical methods like ball milling, chirocrushing, homogenization are used for the preparation of nanocellulose. High pressure homogenization is a common technique which uses narrow channels to form nanocellulose. Similarly, microfluidization also uses narrow gaps to produce nanocellulose. Chirocrushing is a technique in which the cellulose is dipped into liquid nitrogen for 2 or 3 minutes. Further crushing them into a mortar pestle creates nanocellulose. Electrospinning is another technique which creates cellulose nanocrystals or cellulose nanofibrils. Nanocellulose applications. Nanocellulose applications involve biomedical applications, water treatment, reinforcement in polymer matrix and hydrogels. Nanocellulose has a widespread use in biomedical application ranging from tissue engineering, 3D cell culture, bioactive implants, drug delivery, scaffolds, and cell cultivation. The most commonly used cellulose for the biomedical application is for the bioactive implants. Some of the bioactive implants includes dental implants, ear or nose implants, heart valves, cartridges, etc. Water treatment. Nanocellulose are casted into films or absorbents, which are used to absorb or extract the untreated water from the water bodies. These are commonly used for the removal of heavy metal ions from the water bodies. Also, they are fabricated into membranes for special applications like removal of flexural inks from the water bodies. Reinforcement in polymer matrix. Uh, uh, this is the very common example of nanocellulose being used as for an application. Combining of reinforcement agent plus an polymer matrix creates a polymer such as sheets, composites, or membranes, following for a wide range of applications. Several hydrogels are casted using nanocellulose, and widely used applications are like green hydrogels, super absorbents for diaper production, and self-healing hydrogels for biomedical applications. This is a graphical abstract, mainly the gist of the review, wherein it involves the extraction of cellulose from the plant sources. These are the cell walls in which the cellulose is secreted. This involves unwanted materials like lignin, hemicellulose, and cellulose. The lignin and hemicellulose are removed using pretreatment, further obtaining cellulose fibers. These cellulose fibers are further treated with acid or mechanically treated to form cellulose nanofibers and cellulose nanocrystals, giving a wide range of applications for hydrogels, biomedical applications, films and packaging, energy, composites, and water treatment. Till now, successfully, I have drafted a review paper on nanocellulose based biodegradable polymers. Currently, the paper is submitted and is under review in European Polymer Journal. These are the references. Thank you.